Welcome to physics. Today is our fourth activity for our motion unit, and it's really kind of the third of our linear equation set that we've been doing. You might recall we started with solving for distance, and then we just did solving for time, and now we're solving for the last piece, velocity. So similar to the other ones, right? It's how you word the question, and it's maybe what kind of information you have, right? So in this scenario, if you're given a distance and a time, well, then the question is, well, how fast would you have to go? What would your average velocity need to be? Again, I used the grandma scenario earlier. So, you're trying to go to grandma's house, and grandma's house is, 30 miles away, and it took you, and let's say an hour to get there. Okay, so you know that it's 30 miles away, took you an hour. Well, what was your average velocity then? How fast were you going in order to get there at that time? So we can now solve for how fast is an object moving if they're under a constant velocity. So here we are. Again, overview of the equation that you're going to be using today. And it's velocity equals distance minus starting distance divided by time. And I wrote that out here for you as well. And to simplify it again, if you don't have a starting distance, you can assume it's zero. So it's really velocity equals distance divided by time. And so we'll see that here in the slideshow. Again, the slideshow identical to the others where, again, we're using this linear equation because distance and time have a linear relationship under a constant velocity. And what that means, again, hopefully this is starting to make more sense as we're going, but if you are moving at a constant speed, then your distance and your time will come together and make a straight line when you plot the data points. And because it does that, we can refer to it as a linear relationship. And because of that, we can then use the linear equation to make predictions or answer questions about a scenario. So again, that's where this is coming from, but we don't want to use this, right? I already previewed the equation up here. This is overcomplicating it, but I always want to let you know this is where it's coming from. This is the math in it. And then now you're going to know the distance, the time, and possibly the starting distance to solve for velocity. And here's a practice problem. So we have distance at 30 meters, and it took 20 seconds to go 30 meters. So what was the average velocity? You put in distance divided by time. You get 30 meters divided by 20 seconds. And your answer then would be 1.5 meters per second. And I hope this is why the units for velocity is what it is. So I hope we see what's going on. And it's really important that we pay attention because in the previous assignments, I said, look at the units for velocity. That will tell you the units for your time or your distance. And they have to match. And in this scenario, you don't actually have to get your units to match because your units will create your velocity. And another way of saying it is your velocity is a distance per time, per amount of time. And so that's why we have the variable for distance per time, 1 second. So again, though, you're taking 30 meters divided by 20 seconds. You can blend the numbers, but you cannot just blend the units. And so we literally keep that division problem in our units. Meters per second is how we say that. So It literally, you can hopefully see that it is a division problem, and the unit then represents that division. So that's really important that we can see that and understand that. So when we go to answer these questions, we're not confused about what the units are. Another word problem example, but identical. Okay, so uh, world speed record in water was set October 8th, 1978 in Australia by Ken Warby. If Ken drove his motorboat at a distance of 1,000 meters, there's a distance, in 7.045 seconds, there's a time. How fast was the boat moving? Boom. There you go, 141.94 meters per second. Again, we just take 1,000 meters, divide by our time, and that'll get your answer. Not gonna lie, don't know why I put it in parentheses. Didn't need to do that, but it doesn't hurt either way. And then again, just for reference, this is y equals mx plus b, but we're rewriting it. We're moving it around a little bit. Okay, now it's your turn to practice. So just kind of quickly paying attention to the units. Meters, second, velocity would be meters per second. Meters, seconds, velocity will be meters per second. Starting distance is in there, so don't forget that one. Now look at this, kilometers, hours. So your units for velocity will be kilometers per hour. Kilometers, hours. Miles an hour. So this will now be miles per hour. Now, we have a couple word problems. Doing your best to pull out the important information. My hint for this first one, question 7, is it is a two-step problem. The first thing you're going to have to do is solve for time, and then you're going to have to find the difference. Well, actually, you can almost call it a three-step problem. Then you're going to have to find the difference in time, and then you're going to be able to find the velocity of speed. The velocity of speed of sound. Ooh, let me rephrase that. The velocity of sound in water. That's what I'm trying to say. Sorry about that. And again, draw a picture. And because again, the next hint I'll give you, this 101.4 seconds would include the time that it was fired. So it is launched from the submarine, and it's going to take time in order to get to its target, 2,000 meters away. So we know how to solve for time, and I put that reminder there for you. So we can solve for time, then it explodes, and the sound waves travel back to the submarine. So you need to know, well, how much time is remaining from how long it took, explosion, and then the remaining time is all that it takes to get back to the submarine 2,000 meters away. And then that's when you can calculate the velocity of sound. So give that your best shot, and of course we'll go over it in class if you have any questions. Last but not least, common scenario here with driving. Okay, and it's even grandma and grandpa. So Marco's trying to plan a road trip for his family to visit grandma and grandpa. He knows his abuelos live in San Francisco, California, 634 miles away from Portland. I looked that up. That's a true statement. Okay, so 634 miles. What is the average speed that Marco needs to drive in order to get their house in 12 hours? It's roughly a day of driving, right? If you're thinking about daylight. So you have a distance and you have a time, miles, hours. So our velocity should be miles per hour. And round to the nearest whole number the best you can. Okay? Let me know if you have any questions. Again, happy to answer anything that you need. And good luck.